Welcome back, everyone. In this lesson, we're continuing our discussion about finding the derivative of a function using the limit definition. And specifically, we're going to do a few more practice problems for different function f of x. And let's remember the definition that we derived in the last lesson. So the definition of a derivative is limit as h goes to 0, f of x plus h minus f of x over h. And the alternate version of this you might see in different books is limit as delta x goes to 0 of f of x plus delta x minus f of x all over, that should be delta x. So basically both of these definitions really are saying the same thing. They're just using a different notation for the time increment from the last problem. So we usually, if your variable is x, that's really going to be an x increment. We can represent it by delta x, or we can represent that by h. And what is the meaning of both of these equations? Basically, they're giving us the instantaneous rate of change of the function f at any given x. So to see where this formula came from, to understand and appreciate what it is, please see this segment, part 1 of this lesson. So now we're going to continue on with our practice problems on finding derivatives. So the next example we're going to solve is the following. Actually, I'm going to go back to an easier one first. Okay, f of x equals x squared. So the question part A wants us to find the instantaneous rate of change at any x. Part B, what is the slope of the tangent line at any, in this case specifically x equals 1. And part C, what is the equation of the tangent line at the point x equals to 1. So let's get started. To find the instantaneous rate of change, we know, we've learned in lesson part 1 that we need to find the derivative. And the definition of the derivative, as we just reviewed, is as follows. So let's just plug it for this function. The function is x squared. So replace every x, substitute x plus h instead to evaluate the first part of this definition. So to define f of x plus h, go back to the definition of f of x, take the x out, and instead plug in x plus h. So there you're going to get x plus h quantity squared. Don't forget the limit part is still there. Minus f of x. Here you just copy the function exactly as you see it over h. Typically at this point, this becomes an algebra question where you need to simplify the binomial, cancel any terms that you can, and then take a limit. So let's distribute this or FOIL it, right? So x plus h times x plus h, that will be x squared plus 2xh plus h squared. Now, if you need to write it next to each other, x plus h times x plus h, and FOIL it. But on the other hand, if you're comfortable, I think it's good to know this formula, that if you have a plus b quantity squared, the expansion is going to be a squared plus 2ab plus b squared. That's a handy formula. It's going to come up a lot, so it's also good to know how to do it that way. And then once you distribute that, don't forget the minus x squared, copy it down. At this point, we realize plus x squared minus x squared are going to cancel. So in the next step, I will rewrite everything, but factoring h from both of these two terms in the numerator. So we're going to have limit as h goes to 0. So what would you have as h is factored from the numerator? So take out an h. It'll be h times 2x plus h, right? In quantity, in parentheses, 2x plus h, all over h. And at this point, all you have to do is remove the common factors, because h is approaching to 0, but it's not necessarily exactly 0, so we can actually remove them. And at this point, take a limit as h goes to 0, and you're going to get 2x. So 2x is the derivative, is your f prime of x, and it's basically a formula that for any given x, it tells us what the slope of the tangent line is going to be. Because remember, instantaneous rate of change is the same thing as the slope of the tangent line at that given point. So if this is your point here, and you're trying to find the slope there. So you draw a tangent line. The slope of the tangent line will be the same as the instantaneous rate of change there. So this particular function was x squared. So that's your standard parabola. And at the moment, they didn't even have to give us a point. They just said find the derivative at any x. And that is 2x. So that in itself, it's so many informations packed in there. So if I wanted a slope here at 1, I would plug in a 1. If I want a slope here at 2, I would plug in a 2. So I don't have to do a separate calculation, a separate table, a separate formula like this for every x. Every x is basically handled with one formula because the answer is in general. So let's answer now what happens at the point x equals to 1. All we have to do is plug in a 1 in there, and that will give us the instantaneous rate of change, also known as the slope of the tangent line at the point 1. So 2 times 1, or 2. So if you want to show the work, you could say this is the same as 2 times 1, because we're plugging 1 into the derivative, right? And then we get basically 2 that way. So that is slope of the tangent line, or slope of the curve, or instantaneous rate of change at the point 1. Now, the second part, or the last part, was what is the equation of the tangent line? Not just the slope, but the equation. To get the equation of a line, we know from algebra, we can use the following form of the equation of a line. So for this one, we need to know the slope, which we have. This is going to be our slope. We need to know the x-coordinate, which we have. That's 1. And we need to know the y-coordinate, which we can easily obtain by plugging 1 into the original function x squared. So y is 1 because plug 1 in for x. Since they told us x was 1, y is the same as f of 1, right? So y equals f of 1. So to get y, always go to your original function, not the derivative, and plug in your given x. In this case, the function was a squaring function, and we're getting 1. So this is our y, and so this is our given x value. Think of this as x sub 1, y sub 1. Some books will call it x sub 0, y sub 0. It doesn't matter. A specific point we have. Slope we also have. Now we can put all of that into this equation to get the equation of a line. So y minus 1 equals the slope, which is 2, times quantity x minus 1. At this point, we just distribute and simplify 2x minus 2 on the right-hand side, and then plus 1 to get that minus 1 from the left to right. So the final answer is 2x minus 1. And you can check this answer. If you go to your graphing calculator, you can actually enter for your y1, enter the original function. For your y2, enter the tangent line, and then observe that at the point 1, they're going to be tangent. This is a good way to check your work, because if you don't notice that they're tangent at that given point, chances are you made a mistake somewhere and you should go back and check your work. All right, so hopefully, with the second example, it looks a little bit easier. With the third one and the fourth one, you're going to say, okay, this is definitely, there's a pattern here. And just like in many math problems, the process is not so impossible as it looks at first, because, there's a lot of similarities going from one problem to the other. The main thing you need to remember is this formula. If the question says find the derivative, and typically on the test, I will say find the derivative using the limit definition of derivatives, because next chapter you will see shortcut rules, and you'll be allowed to use shortcut rules for some questions. To distinguish when you should use one versus the other, I will say if I want you to do it with this method, I'll say use the limit definition. And I know some of you have seen calculus in high school, but sometimes they don't emphasize the theory so much, so you may only have learned shortcut rules. So please make sure for the homework in this section, show all the work using this method, and on the test, read the question carefully. If it says show the work using definition, you got to do all of this. All right, one more example. So this will be a good one to stop the video, work it out on your own, and come back and check your results. So I hope you had a chance to get started at the very least with this problem, and hopefully maybe you even went all the way to the end. We're supposed to find the derivative. Needless to say, in this section, we're doing everything the more rigorous approach, not using a shortcut rule, but using the limit definition of derivatives. So what was the limit definition? Here it is. We need to begin by finding f of x plus h, and that requires that we take every x out and replace it by x plus h. So take this x out. If you have more than one, every one of those have got to go. Instead, will come in the new input, which in this case is x plus h. So first I'm going to write it. So 2 times, without any simplifications, so 2 times x plus h quantity square plus 3 times x plus h plus 1 minus, now subtract the function as it is. But in this situation, if there's a minus in the middle, I always recommend to put a parenthesis after it because the minus will get to be distributed all around. So minus, in parenthesis, you copy the function exactly as you see it above, all over h. And in the next step, I'm going to distribute the negative sign, and I'm going to distribute the binomial and all the coefficients in front of it. So x plus h quantity square, you're going to need to FOIL that, right? X plus h times x plus h. And once you simplify it, you're going to have 3 terms. The negative 2 will have to be distributed to each of those 3 terms. So just a quick reminder that when you distribute x plus h squared, you should get x squared plus 2xh plus h squared, right? But don't forget now to distribute negative 2 to each and every term. So negative 2x squared minus 4xh minus 2h squared. And then distribute the 3x plus 3h. And don't forget the plus 1. Next, distribute your negative sign. So each of the terms afterwards will change their signs. We have plus 2x squared minus 3x minus 1. At this point, cancel away any common, rather any opposites. So for instance, negative 2x squared, positive 2x squared, plus 3x minus 3x. At this point, we expect quite a few simplifications. If you're not getting that, check your signs. Maybe you forgot to distribute the negative sign in the previous step. So this will be a good place to check that. And then as I'm rewriting the numerator, typically as I do, I'm going to factor out an h from each and every term. And that will leave me with h times quantity negative 4x minus 2h plus 3. Close the parenthesis, all over h. Now the h from the top can also be canceled with the h from the bottom. And at this point, take a limit as h goes to 0. So that means basically at this point, you can substitute 0 for h, and that will leave us with negative 4x plus 3. So remember, this is your derivative f prime of x, and this is the slope of the tangent line, or the instantaneous rate of change at any given point x. In part B, they want us to find slope of the tangent line at 0, so I'm going to plug in a 0 in the above. So f prime of 0 will give us a slope at that point, which is negative 4 times 0 plus 3. That's 3. So that's our slope. And now to find this equation of the tangent line, remember that was part C. I need to know, so I have an x coordinate. I need to know the y coordinate. And I already have the slope, right? To get the y coordinate, remember, you need to plug in the x value into the function, right? To get the height at that point. So we know the slope, x is given, so plug it into y, or f of x. And if you plug in 0 everywhere you see an x in the equation way up there, this disappears, you're just going to have 1. So that's our y coordinate, 1. So we have everything we need to get the equation of the line. So y minus y1 equals 3 times x minus x1. So y minus 1 equals 3 times x minus 0. So you have y equals 3x plus 1. That is the equation of the tangent line. And again, you can graph the original and the tangent line together if you'd like to check your answers. And I went to desmos.com to get a graph. And remember, we're trying to get the tangent line at 0. And in this situation, we can verify that at 0, the tangent line, which is y equals 3x plus 1, and the original parabola, they indeed appear to be tangent at that point. So we know the slope at the point 1 of the original function, which was 3. And in addition, we also know the equation of the tangent line. That is an additional question. It doesn't have to be asked for every single problem. So read it carefully. You don't have to do this step unless they ask for it. Typically, they'll say, what is the derivative? And they'll say, what is the slope of the tangent line or the instantaneous rate of change? And sometimes they'll also ask for the equation of the tangent line. Okay, 2 more examples about finding slope or finding the derivative. And these are not polynomials, so they're going to be a little bit more complicated, or again, the first time you see a problem of this kind, it may look complicated. Second time you see another one with a quotient like this, it may not be as complicated. So let's find the derivative using the limit definition for the function f of x equals 1 over x. So again, here was the definition that we've used several times already. So what is f of x plus h for this function? So replace every x with x plus h, right? It's going to be 1 over quantity x plus h. Okay, so first you replace x with x plus h. So this x is replaced. So we have 1 over x plus h minus the original function 1 over x all over h. Now, to be able to simplify these quantities, I need to get common denominators. So I'm going to multiply this top and bottom by x and this top and bottom by x plus h. And I'm going to rewrite the result in the next line. Notice that those two quantities now have the same common denominator, and that common denominator is x times x plus h. That's my denominator. In the numerator, x times 1 is x. And don't forget that minus will be distributed. Negative 1 times x is negative x. And negative 1 times h will be negative h, which I will simplify that in the next step as such. Okay, so at this point you have x minus x. They cancel. So you have negative h. So these x's cancel. So you have negative h over this denominator. And the bottom, if you look at it as h over 1, it can be reversed and multiply with the top. So I flip the bottom and multiply with the top. You see at this point the x's are gone. So can we then cancel this h with this h? Yes, and only because the x's are gone, right? So now it becomes a factor. So this h is a factor of the top, 1 times h, factor of the bottom. So now you can cancel those h's. So the answer will be negative 1 over, and don't forget the limit part in front still. So you have the h's are gone. You have negative 1 over x times x plus h. And now take a limit. This is the point where the limit notation will disappear. Take a limit as h goes to 0. So now you get negative 1 over x squared. And what was the meaning of this? Slope of the function 1 over x at any point x. I didn't ask this at first, but what if I want to know the slope of the original function at x equals to 1? All you would have to do is plug in a 1 into this answer, which will be negative 1 over 1 squared. That's negative 1. And of course, we can also ask the equation of the tangent line, but for this question, I didn't ask that, so I'm just going to stop the question here. Technically, if the only question said was find the derivative, you're actually done right here. Here is your derivative, f prime of x. And I only did an extension question by asking you, what is the slope at x equals to 1? But that was not a part of the original question. Okay, the last example I want to show you is f of x equals the square root of x. And this one, I think I'm going to give you a hint. I'm going to give you the answer, and hopefully you'll fill in the details there. So what is the derivative of squared function? Let's start by applying the definition. By now, you know what it is, right? Limit as h goes to 0 of f of x plus h. So replace the x with x plus h. That'll be the square root of x plus h minus f of x. Write the function again. So that's minus root x all over h. Now, how would you take a limit like this? If you plug in a 0 right away, you can have root x minus root x, which is 0, over the bottom is 0, indeterminate form, right? So this is precisely the situation where we learned in the last section. You have to get rid of the indeterminate form. If you could factor, you would, but this is not something that you could factor. But we learned another technique, right, for dealing with radicals. And that technique was multiplying top and bottom by the conjugate. So that's what we're going to do here. So simplify this, and to get rid of indeterminate form, we're going to multiply top and bottom by the conjugate, which is the one that has the plus sign of this numerator. So multiply the top with that and the bottom with that. So you're multiplying the top by the square root of x plus h plus square root of x all over the same thing. Notice multiplying top and bottom by the same thing is as if you're multiplying the whole thing by 1. It doesn't change the value. And we've seen this before, right? It'll help us rewrite it in a different format. So simplify your top. Once again, you have a minus b times a plus b. We've seen how to simplify that, right? So this would be a good point to take your time to finish the problem. And please come back and check your answer. So as you're distributing these, you're going to have a squared minus b squared if you're using difference of two squares method to do this. So you square the first one, you lose a square root, minus square the second one, you lose a square root. So this is the rule we're using there. And the bottom, don't even simplify it. So simplify the numerators now. The plus x minus x, they cancel. And now that those are gone, the only term left is h. At that point, you can also cancel the h's. Okay? And sometimes it's good to do that in 2 steps. That's what I did here. So cancel the x's, and there's a single h left on the top. Now that h can be canceled with the h on the bottom, which is a factor. You see why it was a good idea not to distribute the bottom, right? Because it's going to cancel it anyway. And at this point, you have a 1 left on the top, root x plus h plus root x left on the bottom, and now take a limit as h goes to 0. So this will disappear. You're going to have 1 over quantity root x plus root x. In other words, 1 over 2 times the square root of x. Remember this result. So square root of x had a derivative of 1 over 2 root x. As we did the shortcut rules in the next section, you're going to see we're going to get the same answer much faster. But at that point, you'll be able to appreciate the shortcut rules because you understand where each and every shortcut rule is derived from. It's really derived by going back to the main definition of the derivative of a function formula. All right, that was a lot of material in a short video, so I know you're going to want to practice, and please take a look at your web assignment problems, your group activity problems, homework questions. So I know you'll have plenty of practice questions to solve. So see you next time.